Welcome back, everybody, to session 4 of Grow Your Own 2024. It's great to see everyone back coding and making really good progress with making their physical Arduinos. Today, we've got a bit of remote control that we're adding. Again, there's the troubleshooting bit at the end, so if you've not been able to come to this session and you're watching on demand, please try and find a way, if you can, to make it to 6 o'clock for the troubleshooting, and we'll be able to help you if you're having a problem. Otherwise, we've got the Christmas Light Festival in Oxford in November, and we'll be at Pegasus Theatre, and we'll get some more information about that later. And you can always get some help from us then. But meanwhile, it's time to get some coding. So, Sophie, are we ready to do some coding?
Session 4? Yeah, I'm ready, and I hope everybody else is. Thank you. And it's lovely to see you all again. I am so looking forward to this session. So before, what we've done in our previous sessions is we've controlled lights, and last time we were controlling lights using a button to turn it on and off, which is always good. But I don't know about you, but I'm really lazy. And I like the world to just work the way I want it to work. And so instead of standing up to go and press a button to turn my light on, what I would like to do is just for the light to turn on when it gets dark enough for me to see it properly. So that's what we are going to do today. We are going to create a circuit that turns a light on automatically when it gets dark. This is always really cool. So I'm sharing my screen. I think you can all see that. And then I'm going to put GYO 5000 because that's me. You've all got different ones. That's me. And then we're logged in, and look, we can see the circuits that we have done, previously, which is marvelous. All right. So what I would say is the easiest thing for you to do is to click on one of the circuits that you did either last week or the week before, so that we don't have to start from scratch. I will go through all of the steps to the circuit and all of the code, but we'll do the bits that we've done before a bit more quickly, just because we've already done them. Okay, so I'm going to make a circuit here. Just thinking about it. And now we are in our circuit building place. And remember, the first thing I'm going to do is I'm going to change its name. So I'm going to call it automatic lights, or auto lights, because apparently I'm really lazy and I couldn't be bothered to write the whole of the word automatic. Right, so there, that reminds me what this circuit does. Now you remember that all of the components are over here. So we're going to start by getting our Arduino, our controller out, and then our breadboard, like this. And the beginning bit of the circuit is just like we have done before. We're going to have a light that is going to be connected to one of our Arduino pins. It's going to zoom in a bit so you can see it a bit better. We're going to have a light that connects to a digital pin that we can turn on or off. So I'm sure you all remember this bit, but we're going to bring our light, or our LED. We're going to put it over here like that. And then next step, we're going to connect it to our Arduino using a wire. So I'm going to go from here down to here and along. I'm going to connect it to pin 4 here like that. My nice neat wires. Dane sent me a beautiful video last week of how you can make neat wires in real life. It made me so happy.
Maybe I'll send that in the chat later.
I think you should. It's really, really cool. So we've got our first bit of our circuit from our Arduino through the wire, through the LED. Now we need our resistor, just to keep the right amount of electricity going to our LED. And you'll remember we want to reduce the resistance, so make it less strong, so that we have a nice bright LED. And I'm going to change this to 220 ohms. Okay, so I've got a resistor like that. And then one last wire, I'm sure you'll all remember, goes from the breadboard on this negative line all the way to the ground. All the way to the ground. So I'm going to go from here down and along and down to the ground. So that is the circuit that we have made several times before. And we can send instructions to pin 4 on our Arduino, and then those instructions will be delivered to our LED. So far, so good. That's stuff we've done before, which is fab. All right, now for the new bit. If you look over here at the components, you'll see all kinds of different components. Do have a little investigate of them, because there are some really cool things that you can do with them. But the one that we want for our next, for the next part of this circuit is down here. It's called a photoresistor. And if I just change to the detailed view, you can see that a photoresistor is a sensor whose resistance changes based on the amount of light it senses. Okay, so we're going to use this special component called a photoresistor. Sometimes it's called a light dependent resistor, or LDR, to tell how bright it is, and then we'll use that to send instructions to say if we want our light to be on or off. So I'm going to pull my photoresistor out and put it on my breadboard over here, next to my LED. So now we have our photoresistor, but of course we need to connect it. Now, you might remember last time that our button needed some power, and it's the same thing. It needed power, it needed a resistor, and it needed a wire so that it could send information back to the Arduino. And we're going to use the same, and we need the same thing for our photoresistor. All right, so let's do the power first. So you will remember from last time that the power, you have these power pins here at the bottom of the Arduino. So we've got this lovely 5-volt power. So we want to go from the photoresistor to this 5-volt power. We'll do that in 2 steps with 2 wires. One wire is going to go from the photoresistor over here to the red line on the breadboard. You see, so it's not on the same line as the resistor from the LED, because that goes to ground, but it is on the other line, the red line down here. Okay. And then we're going to connect it from this red line. This is our power line. We're going to draw a wire all the way from the power line, all the way down here, down here, and then up to our 5 volts. I'm just going to make it a little bit closer to make it a little bit neater. Like that. You see? That's not quite straight, is it? There, that's better. So the next thing we're going to put in is a resistor, just like with our button. We need to control the amounts of electricity and power flowing through. So I'm going to switch this back so that we can see more at a time, because we all know resistors now. I'm going to move a resistor. I'm going to get a resistor, and I'm going to take it from the other leg of my photoresistor to the same line on the breadboard as the resistor from the LED, from the light. Okay, so it goes along to the same one. So now we actually have a complete circuit. So let's trace it together. From our Arduino, from our power here, we go from the 5 volts, we trace along this wire all the way up to the red line on our breadboard. We follow along the red line on our breadboard up to this wire, to this column on the breadboard, through the photoresistor, back through this next column on the breadboard, through the resistor, along the blue line on the breadboard, and then back down through the wire to the ground. So you see, we have got a complete circuit now, and that would work beautifully, except the Arduino has no way of getting the information from the photoresistor, so it doesn't know how dark it is. So that is our final step. We want a wire that is going to take the information from our breadboard, from our photoresistor through to our Arduino. Now, last time, you'll remember we took the information from the button to another one of these pins at the top. And that worked fine for the button. But actually, for the photoresistor, we're going to take it to one of these pins down here at the bottom. Now, the pins at the top are what we call digital pins. So they're really good at knowing if something is on or off. And that's really useful if the button is on or off. But if you've got something that isn't like on or off, but it's like, it's quite dark, it's really, really dark, or it's a bit bright, it's getting brighter, or help, I need my sunglasses, it's too bright. If there are lots of values that it could be, then we want to use the pins down at the bottom, which are called analog pins. And those two words, digital and analog, they're used in electronics and electricity all the time, and in lots of other things as well. So we want to take a wire from the photoresistor over here, all the way down to one of these analog pins. Okay, so I'm going to click from here. I'm going to go down to here, over here, and then down here, all the way along, and then to pin A0, like that. And now we have our complete circuit. What I am going to do before we do the coding bit, though, is I'm just going to change some of the colors on the wire. Now, the color of the wire doesn't make any difference to how it works or anything. It will just make it easier for us to tell what is happening at a glance. So what I'm going to do is I'm going to change this wire here that is all about power, going from the Arduino's power socket to our red line, our power line on the breadboard. I'm going to change that to red by clicking on the green and then changing it to red. And then I'm going to also change the one that goes from the power to the photoresistor to red, because that's all about power too. Like that. Okay, so you can see that immediately that makes it a little bit easier because we can tell which wire is which on our diagram, and it just makes it easier for us to see. I'm going to make two more color changes. I'm going to change this one that's connected to the ground. I'm going to make that brown because that's sending it to Earth, sending it to the ground. That goes to brown. And then this one, which is sending information into the Arduino, that's an input, I'm going to make that a yellow wire. And then this green wire is an output, sending instructions out to our LED. All right. Red is power, absolutely. So how is it going, everybody? Give me a thumbs up if you're ready to do the coding, or if we stay on this bit for a bit, that's completely fine too. Good job. Oh, you're all being so speedy today. This is marvelous. Fantastic. All right, well, let's have a look at the coding. Sometimes Tinkercad can be a bit laggy, so you just have to be a bit patient with it. But like we keep saying, don't worry if you're not quite there. You can always catch up with the recording or with the worksheet. All right, so we are going to do our coding bit now. So we need to click on the code button up here. And as normal, Tinkercad says, oh, would you like to do this code? This code would be really fun, but I think we're going to do some much better code. So let's delete the code that Tinkercad says. There we go, put it into the bin and start our new code. So you remember last time we used an if then else loop. So that was just asking the Arduino a question. Is the button on? Is what we asked last time. We're going to ask the same thing, but instead of saying is the button on, we're going to say, is it dark or not? So let's start with control, because what we want to do, we want it to always be working. So if it's always asking the question, is it dark? So we're going to start with a forever loop. And then let's get an if then else loop here in our forever loop, like this. And we're going to say, if it's dark, then turn the light on. If it's not dark, if it's light, then leave the light off. Okay, let's do the output first, sending that instruction to our LED. So you remember that we wanted to send this instruction out to a pin. So let's do set pin to high, so turn it on. But look, my LED is connected to pin number 4. Okay, so I need to change this to pin 4 and then turn it off. If it's dark, we're going to set pin 4 to low. Now we just need to do the question bit. But before we do the question, I'm going to mention something that is really, really important for computer coding. In fact, I think it's the most important thing if you're doing any computer coding. Not everyone agrees with me, but I think it is. And that is something called comments. Now, what a comment is just a bit of text, like a note to yourself that's in the code, but is not instructions to the computer or anything. It's just a note to you or to whoever else is reading the code that tells you what is happening in that bit of code, what you're trying to do. And that's really useful if you're like me and you tend to forget what you're doing. So writing myself a little reminder, a little note is helpful. But the reason it's so important is actually normally for science and for all of the code that you use every day that runs your mobile phones or anything that happens, it's not just one person that sits and writes and thinks, right, I'm going to create a game for a mobile phone. It's a team of lots and lots of different people, sometimes who work all over the world, and they all work on the same bit of code. Certainly in science, we have hundreds and hundreds of people who write the code that control our experiments and understand our data and things. And we all have to work together. And so it's really helpful to have a little comment saying, like, oh, I've just tweaked this, because then you don't have to send an email to 100 people going, I don't understand what this code is doing, because it's already there. So if you go to notation in our blocks, you can see that we can put our codes, our little comments here. So you pull out this comment here, and I'm going to put one here. You see Tinkercad suggests that we say helpful single line comment here. What I'm going to put is if it's dark, turn LED on. And if I put it here, that means that's what this bit of the code is doing. Then I'm going to put another one here and say, and learn how to type. If it's right, turn LED off. Okay, so that comment can be anything, just so that you remember what it means. I hope that looks better for you all. Oh, you're completely right. I entirely missed to say what value of the resistor should be that's connected to the photoresistor. Sorry, everybody. I often forget to say that for this bit, because a good value for the resistor is the default one, the one that Tinkercad automatically puts. So yes, it should be 1 kilo ohm, which is the one that Tinkercad automatically gives you. All right, I can see that lots of you are ready. Fantastic. Brill. And yeah, the O is omega. That's where it comes from, which is a Greek letter. All right, now the final bit of this code to start with is we want to put the question, we need to put the condition. So what question do we want to ask our, oh, just disappeared. Ask our Arduino, okay? Now, the question is, how bright is it? So let's go to math. We want to compare two numbers, just like we did before with our button. And we're going to put into this hexagon shape one of these, so that it's one number different to another number. So let's pop that in there. It makes a very satisfying noise when you click it in right. And we want to know, is it dark? All right, so we want to get an input because we want to see what value the photoresistor is. Now, if you click on input, you'll see lots of different ones. And we want to read analog pin. You remember we said that these were all called analog. So that's the number that we want to look at. Read analog pin. Just going to make this a little bit bigger so you can see it all. And I connected mine to pin A0. So that's the right thing. Now, I want to know, is it dark? So I want to know, is it less than a certain number? Now, the number that gets sent to the Arduino depends on what photoresistor you've got and all kinds of other things. So we're just going to put I'm just going to put 200 in there to start with, and we'll see if that works. We can test it out. So I'm going to see if it's bigger or less than 200. And if it's less than 200, I'm going to call that dark. Okay. All right. And that is some code. How are we doing? Shall we simulate it together? Test out if it's working. Give me a thumbs up if you're ready to test it out. So I've got my code and I'm going to click Start Simulation. All right, so my light has gone on, which means that my resistor is saying that it is dark. Now, that's because, oh, sorry, I'm just going to try and move this so that you can see it. So to change the value that the photoresistor thinks it sees, this is a simulation, so it's not actually really light or dark. All right, so you remember last time we could turn the button on or off by clicking on it? Well, we do the same thing. We can pretend it's different values, it's different brightnesses. If you click on your photoresistor, you'll see this little slider thing comes up. And at the moment it says, oh, I'm really, really dark. It's the nighttime. But if I move this slider up, you'll see towards the sun, you see my light went off because it was getting brighter and it's dark all the way down here. But if I get to here, it's bright. Now I could change this value here in my code. So if I made it, say, 400 instead, and then start the simulation. It's dark, but you see it stayed bright. It stayed on for longer. That's because I've made this value bigger. Okay. But if I go back, it goes bright again, which is brilliant. Exactly what we wanted to do. So if we were making the circuit in real life, then it would be going off and on with the sun rising and setting, or us turning the light on and off, or something like that. Okay, so did that work for everybody? Give me a thumbs up if it's working. So you just, to get the slide bar, you should just be able to click on the photoresistor. You should also come up with a thing that says photoresistor. If it's not, if you click on it and it doesn't show up, if you click away from it, right, and maybe click on a wire or something, back, and then click on this, then it should appear. And then it should pop up like that. And I can see that lots of people it's working for many of them. Absolutely. So a few things that it's easy to get wrong in this circuit that I often get wrong. is sometimes the wires, check that the wires are going to the pin numbers that you've written in your code. So here you've got my photoresistor is connected to pin A0, and my light is connected to pin 4. So you can see that connected to pin 4 and pin 4. If it's not working, but when you're sliding the light around, you could try changing this number. So I've changed that to 500 now, and then let's click again. And it's light when it's really dark, but when it gets to up here, when it gets to be bright, it's turned off, but you can see it's changed where it changes from on and off. And make sure that one says high, turn the light on, and one says low, turn the light off. Okay. All right. Doing well, everyone. So yeah, just to find it, you just need to click on this, and then it should pop up. Click on the photoresistor, and then your slider should pop up. All right. While we're getting that, we're just going to, I'm just going to show you what's possibly the most useful thing for Arduinos. It's a really, really helpful thing to do. So if you click on output, there are lots of different commands, and we've used some of them, but we haven't used all of them. Now there's this one thing here that says print to serial monitor, and all that means is print to screen. So what we can do is we can use this to get us to tell, to get the computer to tell us what the Arduino is seeing. So if you click on this print to serial monitor and pull it in, I'm going to put one here in the first section of our if loop. But instead of just saying hello world, what I'm going to print out is what the photoresistor is telling me. So that is, remember, in input, read analog pin A0 with a new line. That just means on a new line. And then if it's bright, we're going to do the same thing. So let's get another output, print to serial monitor in this one, and read the analog pin. Okay, and you'll see down here at the very bottom, which might be tricky if you can't see the very bottom. Is that working? The very bottom, kind of in the middle, it says serial monitor, and then that will pop up with a note. So we're going to start our simulation. Thinking about it, now you can see that my photoresistor is telling me this number 6, so that's the number that it's reading. If I click on the photoresistor and make it brighter, I can change it. It's gone up to 70, 250, 300, 400, and now at around 500 it turns off. So here it's 464 and my light is on because it's dark. But if I move it up, it goes to 624 and my LED is off because it's bright. So this can be really, really helpful to help us understand what the Arduino is seeing, because sometimes it sees things that we don't think it should be seeing at all. All right. So how's it going, everybody? Can see some people are doing well, which is fantastic. In a second, we are going to start building the circuit in real life. Now, photoresistors are a little bit tricky, so don't worry if you haven't quite got it working. Dane and Sarah are on it and they're looking at your code. and we can help you in the troubleshooting as well. And remember, this is all recorded, so you can always watch it back online, back afterwards. Okay. So if it's not quite working, then remember to pop your number in the chat so Dane or Sarah can double check. But while they're checking, just make sure that all of your circuit is exactly the same as it is on the screen, and all of your code is the same as well. Fantastic. I know that looking at some of you, it's working. That is brilliant. Good job. Good job, everybody. Ready to do the coding. All right. So while we are, some of you are finishing up that circuit, it's fantastic. Yours works well, good code, brilliant, good job. We are going to start to build our circuit in real life. Now, I think I might leave, would it be helpful if I leave the screen share up for a minute, just so that we are, everybody can see the code. And while we build the first part of the circuit. Dane looks like he might have frozen, so I'm going to do that. So the first bit of the circuit is the bit with the light. So if you didn't unbuild your circuits last time, then that will just be, be exactly the same. So I'm just going to put my LED in, my wires. I'm going to try and put my LED in. I've got a stubborn LED. There we go. And my resistor. And you remember, you just has to be exactly the same as on the Tinkercad circuit. And so once I'm building my first circuit. Oh, Dane has very helpfully put the picture in the chat as well, so that you can see it there. So even when I stop sharing my screen, we'll be able to see that. Thank you very much, Dane.
No problem.
All right. And then this goes here. Okay. So remember, one last time on Tinkercad, if you want to change the light that your photoresistor can see, you just click on your photoresistor, this squiggly thing, like that, and then it should. Oh, I'm gonna. If you've started your simulation.
Sorry, Sophie. I keep there's been quite a few. I've checked a few people's code, and what I'm doing to fix most of them is my code is slightly different to Sophie's code. Where Sophie has if read analog pin A0 is less than 500. That doesn't work for me. Mine needs to be 200. So if you are also having problems and you can't see a change, try changing that to 200, because that is what is fixing quite a few other people's code that I'm having a look at. So I've got sort of 3 or 4 different nicknames on the go. So if you haven't helped you yet, I am going through it step by step. You'll have to be a bit patient, but try changing that number to something a bit lower, and that might help you. Sorry to interrupt, Sophie.
No, that's a really good thing, Sarah. One other thing that you can look at is if you have your serial monitor up, see what the value it gives out when it's right down at the bottom, when it's all dark, and then see what the value is right up at the top, because each photoresistor and each circuit is a little bit different sometimes. So mine goes from 6 at the bottom to 679 when it's as bright as it can be. So pick a number that's somewhere between those two. And then you should be able to see the difference as it goes up. Okay. Fab. All right, so you can see the number changing down here in the serial monitor as I change my light level. And my light goes on. Brilliant. I can see lots of you working. That's fantastic. And yes, just a reminder, the resistor with the LED is 220 ohms, not kilo ohms. Remember, you need to change that to ohms. And the resistor with the photoresistor, I have set to 1 kilo ohm. Okay, right. Okay, so I'm going to stop my simulation and stop my share just so I can show you the real thing. Like we said, don't worry if you're not quite there and you're still working on the Tinkercad, because we are recording this and you can always watch it back. I'm going to stop my share and then I'm going to turn my Arduino camera on. And try and spotlight it for everybody. Spotlight for everyone. Okay, so now you can see my Arduino, which for some reason is a little bit blurry today. There you go. And you can see that while we were doing that, I've made the circuit that we've made before. So I've got my wire going to my LED, and then I've got a resistor. And then from the resistor, I go back down to the Arduino to the ground. Now, you will put your ground normally on this side over here, but my Arduino is a little bit broken. And so I've had to put it elsewhere. Now, the next step you need to do is find your photoresistor. Now, it looks like this. So at the top, it's a rounded thing, and it's actually got that pattern on that you can see on Tinkercad, the kind of squiggly lines, and it's got long legs, kind of like an LED. Yours will probably not be as scrumpled up and bent as mine are, but I've been using this one for quite a while. My phone is having difficulty focusing today, isn't it? There you go. And can you see the top has that pattern of lines on it, just like the pattern that's on Tinkercad. Okay, so what I'm going to do is I'm going to put it onto my circuit, my breadboard. Get it in. Sometimes you have to be a bit patient with wiggling it in the right place. And then I'm going to get my resistor and put it in from the leg of my Arduino on this side here, so furthest away from the LED. From that line, making carefully sure that it's in the right line, to my blue line on my breadboard. That is already connected to my Arduino. Oh, sorry, my thumb's in the way because it's being a bit difficult. There we go. So you see, that's connected like that. Just going to try and squeeze it up a bit so it's a bit neater for you to see. There we go. Then I'm going to connect my Arduino to the photoresistor. So that yellow line, that yellow wire that went from one leg of the photoresistor over to analog pin 0 on the far side of the breadboard of the Arduino, all the way over here. Okay. So just two more. I just need to get that power to my photoresistor. You remember those red wires that I needed. So I'm going to do one from my photoresistor leg over here to the red line on my breadboard, all at the edge here. and then one from the red line of my breadboard to the power over here. 5 volts. Sorry, I'll try and do it from the other way. My wires are a little bit short to do this out easily. Like that. Now I have all of my circuit made, which is brilliant. How's it going, everybody? The next step, you'll remember, is to we're going to send our code from Tinkercad to our real circuit, and then we're going to cross our fingers and hope that Duino has deciding to behave today. All right, Dane looks like he's still making his circuit. How's it going?
I'm a little bit behind, but I'm catching up.
That's okay. It doesn't matter if we're behind, remember, because we've got the recording.
Absolutely.
We've got the worksheet as well, and we've got the troubleshooting. So we can all go at our own pace to get everything sorted. All right. Sarah and Leo have both very kind. Sarah's popped the Duino app into the chat, which is marvelous. So you can click on that, everyone, to get started. All right. So how's it going? Are we ready to transfer our code to the real circuit? Or like Dane, do you need a little bit more time to build your circuit in real life?
There we go. Right.
Give me a thumbs up if you're ready. You're building yours, that's completely fine. Dane definitely looks as if he's still building his.
I think I'm there now. Yeah.
Fantastic. Good job, everybody. You're all doing so well. The most important thing with coding is doing it together and persevering, because my code, at least, I don't know, maybe this is just me, but I think code often you have to try a couple of times to get it right.
And it's best not to rush too, because if you rush, you can sometimes make a mistake and it takes longer.
Absolutely.
So doing it at your own speed is the best way of doing it, I think.
Definitely. And especially with the circuits, because they're so little and fiddly. And I'm not very good at things that require like fine motor control. I tend to break stuff. So I have to be quite patient with it. I have to be quite patient to make sure I've got everything in the right bit. Okay. All right. Now we've got a few more minutes. So what I'm going to do is we're going to transfer our code from Tinkercad to our real Arduinos, so that that's all there on the recording. But don't worry if you're not there, because we can go back and check things out during the troubleshooting session, and also will be on the recording, so you don't have to worry about that. All right, so I'm going to plug my Arduino into my computer using my wire. I just had to turn my Arduino around because I've only got a short wire with me today, and it won't fit otherwise. There we go. So you can, there we go. So you can see that the Arduino is connected because it's got these lights on, these two little lights here that says, yep, I'm getting power. That's always the first step. Right. It can just stay like that because otherwise I'm going to hit it. All right, now I'm just going to share my screen again so that we can so that we can do this next step together. So here is my lovely code, all set and ready to go. I'm going to switch from blocks, where we edit it, to blocks plus text. So that's just translating it into another language. And then I'm going to copy all of my code here. So I'm going to highlight it all and then do Control-C. And then in the Duino app, which Sarah popped in the chat for you all, I'm going to create a new project. I'm going to call it Auto Lights. I'm going to take the O out of lights because that's not real. And it says, oh, would you like to do this code? We still don't want to do that code. I'm going to delete the code that Duino gives us and paste it in here. These are exactly the same steps that we've been using for the last couple of weeks. So you're all really good at this. So the next step is to make sure that it knows that it's doing, it's talking to an Arduino. So we're going to select a device. We're going to move to, mine is called a USB serial device, COM7. Yours might be called Arduino, or it might be called something else. Remember, for reasons that we don't understand, each computer calls it something slightly different, just a bit annoying. We're going to connect that. And when I connected that, the light on my Arduino flickered. It might not do that with all of yours, but that's what happened for me. And then the final step is to send it to the code. Send the code to the Arduino. So let's click on this. It's thinking about it. It's sending it. And it has sent it to my Arduino, which you can tell because my light has gone on and it's very, very, very bright. Now, one last thing before I hand back to Dane. I hope that's worked for all of you, but like I said, don't worry, mine isn't quite working properly. Now, the real Arduino, the real photoresistor, is going to go bright and dark at different levels to your to the pretend Arduino on the computer that we simulated with Tinkercad. So what you can do is click back into your code and just try changing this value here. So you could change that value and just test it out, do a bit of trial and error. So just change that here, because that is what we were asking, is our analog pin A0 less than 200 or 300, and then send it again. Or to get the serial monitor that we had in Tinkercad, you can click on this button here on the left that says monitor. And then if you go down here and change, I've forgotten what number it is, and change this thing that says something bowed. It's just the kind of rate at which information gets sent to your computer, to 9,600, you'll see that a number is being sent to my Arduino, and that number changes depending on whether or not I put my, I've turned my Arduino cam off. That number changes depending on if my finger is over the Arduino or if it's on, or if it's off. So it's over or if it's off. Okay, so I can change my value here, and that will tell, so I can figure out what number I want to put here. Let's say 50. Fantastic. Good job, everybody. Really, really well done. You can see the monitor here that tells us what the value of my photoresistor is for all of the different values. If I put my light on or off. You've done really, really well. Really, really well today. You can just figure out, you can just try different numbers in that code to see what the right number is for your room and your light and things. All right, so good job, everybody. If you've got any questions, we will be sticking around for the troubleshooting next, but you can always just watch us on the recording as well. And I think Dana's going to share some cool stuff about what we're going to be doing next week.
A little bit, and I'm happy that I've made mine work as well. This is great.
Yay.
So my settings are slightly different to Sophie's. So my photoresistor was set to 200, and another way of controlling it is I have another light here. So my Arduino thinks it's dark, even though it's not terribly dark, but I have my phone light here. So if I shine my very bright light over the top of my photoresistor, it knows, and it's so bright that it's sort of, so bright that it's kind of, but you can see it flashing with the different colors. And if I make it really bright, you possibly can see that the flashing stops. So if I move it away, it comes back. So that's another way to control it. So changing the ambient light or sending a specific signal. So I'm just using my phone to send a specific signal from this device over here. And that's how some satellites send messages back to Earth, is they send a specific signal with a light beam, and detectors on the ground will spot something going on from space. So I'm happy that that's working, because that doesn't always work for me. Okay, right. So for next week, we're going to do some crafting. And if you can remember from last time, I made this little egg box. So I've got it connected to my external battery, so I can just press go and it will just turn on. So I'll show you how you can make a little bit of a casing out of an egg box, and how you can start thinking about how to make all of this stuff inside fit together. So if you can save some egg boxes or other cardboard boxes, I have another, I had something in the post come, so I've got this really nice big box the size of an A4 piece of paper, and we've got something that we're going to share with you later. So I've got a secret design on this, which happens to fit nicely into this A4 paper box. And so it might be that I make a much larger version of the egg box design. So any kind of cardboard box that you have, it's really cool if you can keep hold of that for next time, and you can start making your own brilliant casing. So obviously our phones and other electronic devices have a specific casing that's made for them, but we can upcycle things like egg boxes and cardboard packaging boxes. So that's what we're going to be looking at next week. So please do keep hold of your recycling. Right, so well done everyone though. That was a really tricky one, getting the photoresistor working and the serial monitor and turning it so that your ambient levels of the light respond properly for your photoresistor. And as Sophie was saying, all of them are different. So this is a really tricky one to get right. And if you haven't quite cracked it yet, please do stay behind and we'll help you out in the troubleshooting bit that comes up next. But otherwise, we're looking forward to seeing you next week for the crafting session. So keep on coding, keep on making, and we'll see you next time. Well done, everybody. Bye.
Good job, everyone. Bye.